Assalamualaikum warahmatullahi wabarakatuh. Introduce, my name is Muhammad Bayu Muklas Aditya with name 194308094 from Group 4 will present the results of our group's work titled Locomotive Diesel Electrics. And before I begin this presentation, I will introduce our group members. The first is Muhammad Zulkarnain with name 194308011 and myself Muhammad Bayu Muklas Aditya with name 194308094 and we are from TKA2C. Well, I immediately started for this presentation and the first I will explain the definition of locomotive diesel. Diesel locomotives are types or locomotives with diesel engines and generally use diesel engine fuel. There are two types of diesel trains, namely hydraulic diesel trains and electric diesel trains. The locomotive which powered by electricity from an electric flow cable is linked to energy storage installed in equipment such as batteries or supercapacitors. Electric locomotives with main propulsion mounted on means with fuels such as diesel engines or gas turbines are classified as diesel-electric or gas-electric turbines and not as electric locomotives because the generator or motor-electric combination only functions as a power transmission. Advantages of railway electrification. First, safety. No passengers leave the facility by themselves. Second, lower manufacturing and maintenance costs, higher power-to-weight ratio, or no onboard fuel tank yields. Can work without the help of other means, faster acceleration, higher steering limit, long range, higher speed limit, less noise pollution or quieter operation, quieter. Faster acceleration is suitable for tracks in urban rail use. Reduced power loss and higher altitudes, or for loss of power see diesel engine, operational costs of fuel price fluctuations, service that include underground stations where diesel trains cannot operate for safety reasons, reducing environmental pollution, especially in densely populated urban areas, can accommodate kinetic energy waste using the brake resistor, comfortable in all angles because the train doesn't have diesel engines under the floor or less vibration. Save energy when either more flexible energy source or can use coal, nuclear, hydro or wind as the main energy source instead of oil. And the disadvantages of private electrification. First, electrification costs. Electrification requires a whole new infrastructure to be built around existing tracks at a high cost. Costs are very high when tunnels, bridges, and other obstructions must be adjusted. Other aspects that can increase electrification's cost are change or increase in train signals needs for new traffic characteristics and to protect signaling circuits and track circuits from interferences by electromagnetic fields. Electrification may require closing channels when new equipment is being installed. Appearance of infrastructure, solid upper flow electric lines, fragility and vulnerability. Overheat electrification system can experience self-disturbance due to minor mechanical errors or the effect of strong winds which cause trains to move smoothly with catenaries. Tearing wires from the supports, damage often occurs not only in one upper electric line, but extend to adjacent lines as well, causing the entire road to be blocked for quite a long time. The third rail train system can experience interference in cold weather due to formation of ice in the conductor rails. F. The high price of copper in remote installations that is not worth it makes the upper flow electric cable an attractive target for scrap metal thieves. Efforts to steal a leaf cable of 25 fuel fault can end in death due to electric shocks, disruption for flying animals, and last, unequal power maintenance. And next, I will explain about pantograph. Pantograph is a tool that functions to zoom in or out on a map or image. Using this tool, one can resize the map according to the desired size. Basically, pantograph work is based on a parallelograms. Three of the four sides of the parallelogram, A, B, and C, have the same vector scale. The scale on all three sides can be changed according to needs. Arrange each pantograph arm to the desired scale. Then place the map to be enlarged in place B, and the blank drawing paper place it in picture A, which has a pencil. Then move B to flow the original map through the observation glass. And there are two pictures of pantograph, and there are two types of pantograph like this. Pantograph has a single or double arm type. Double arm pantographs are usually heavier, requiring more power to raise and lower, but may also be more tolerant of errors. And this is an electric locomotive, and there are much part of these locomotives like a overhead line, and then this is a pantograph with the color red, and circuit breaker, main receiver, DC link, main inverter, and local cooling fans, compressor, battery, motor blowers, and three-phase AC motors, auxiliary rectifier, auxiliary inverter, main transformer, and then two other three-phase AC motors, axle brush, and three-phase AC motors. And this is the main inverter. And this is the diesel electric locomotives. And this is also there are much part in this locomotive, like a batteries, cap, and control stand, electronics controls, rectifier inverters, air intakes, auxiliary alternator, main alternator, diesel engine, turbocharger, drive shaft, gearbox, radiator fan, radiator sandbox, air compressor, truck frame, fuel tank in one side and air reservoirs in other side, and then motor blower, traction motors, pinion and gear and wheel. How does an electric diesel locomotive work? Why does the train use diesel fuel? Actually, diesel fuel has become the fuel of choice for locomotive use because of its lower volatility compared to other fuels. Volatility here means the nature of the tendency of the fuel to change into a vapor phase. High vapor pressure and low boiling point indicate high volatility, and in addition to the low level of volatility, another reason behind the use of diesel fuel is relatively lower cost and doesn't include items that are difficult to find. Then how can these two forces work together? Early on, diesel fuel was stored in a storage tank and sent to the engine by an electric fuel pump. This diesel engine itself is an internal combustion engine consisting of several cylinders connected to a crankshaft. When the fuel is ignited by strong compression, the piston will push up and down. The movement of the piston will then rotate crankshaft. Diesel engines that are connected to the main generator will change the use of power, which originally used diesel power will be converted into electric power. After that, the converted electricity is then distributed to the traction motor through a circuit formed by various switchgear components or distribution panel that distributes the load to the smaller capacity panel. The technicians who design such electric engines control the locomotive's power output, which is controlled by the excitation will current to each of its winding by using an electricity-controlled throttle. The more fuel that is injected into the engine cylinder, the more the electric output increases. Each traction motor is directly directed to a pair of cogs. The use of electricity as a transmission for locomotives is far more reliable than using mechanical transmission and clutch. Okay, but the presentation that we can deliver, if there are errors in writing or pronunciation, we apologize profusely. And that is all. And thank you. Wassalamualaikum warahmatullahi wabarakatuh.